Hi. Today we're going to be looking at word problems and building models from a word problem and then solving them, the equations that we generate. These problems are taken from the textbook, and I compiled some of them that are the most helpful. And each video is just going to be one of the problems. So the first problem says, let P equal x comma y be a point on the graph of y equals x squared minus 8. Okay, so it can be any point on the graph. And so let's start by perhaps drawing what that looks like. So we have the graph is y equals x squared minus 8. We've done transformations, and we know that that is a parabola, and then it is shifted down 8. So it looks something like this. Let's see if I can get that nice, whoa, curve in there. It's pretty hard to control my pen on this. All right, so here is our parabola, and then we're talking about a point somewhere on it. That point can be anywhere. I'm going to put it like right here to kind of cover up that little mistake. So this point is P, which is x comma y, and it's really any xy on that graph. So in part A, it says express the distance d from P to the point 0, comma, -1. So the point 0, comma, -1 would be right here, right? 0, -1. And so what we're talking about is this distance, right? This distance would be d. Of course, it would be different depending on where P is on the graph. So it says we're going to, really start using algebra in this problem, though. It is really not a graphing problem. Most of these are going to be algebraically solved. All right, so in A, it says we're supposed to find the distance between the 2 points. And the one point is 0, comma, -1, a legitimate point, and the other point is a variable, x comma y. So the first thing we're going to need is, since we need the distance, we need the distance formula. So let's review that. D equals the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay, so all that is saying is there's a point, x1, y1, there's another point, x2, y2, and we can find the distance between them using this formula. In other words, we're taking the difference between the x points and squaring that. We're taking the difference between the y points and squaring that. And then we add them together and we take the square root of the entire thing. If you recall, the distance formula actually comes from the Pythagorean theorem. We're not going to go into the derivation of it, but that's probably where you saw it first, was near the Pythagorean theorem. All right, so in this problem, point P, which remember is x comma y, and the point they give us, 0, comma, -1. So let's plug those into the distance formula. Okay, you could actually use either point as x1, y1. Let's just use this first one, x and y. So that would be x minus 0 squared plus y minus a -1, right? So minus -1 squared. Okay, so next we could simplify that a tiny bit if we wanted to, because I can see x minus 0. Oh, don't really need the x minus 0, do I? I just could put x squared. And then in the y's, I should probably simplify that. Oh, I missed a parenthesis there too. Should probably simplify that to y plus 1 squared. We are not actually finished with part A because it says as a function of x. What we are really trying to solve for is the d of x, but then we can't have a y in the equation. The good news is we know what y equals. Y is equal to x squared minus 8, right? Wasn't that given in the problem? Y equals x squared minus 8. So for the y, we're going to substitute in x squared minus 8, and then we'll simplify a little bit again. So we first have x squared, then in the parentheses, the y is x squared minus 8, and then we still have plus 1, and then squared. Okay, so this would be the d of x. We're finally there. We would have x squared plus x squared minus 7 squared. Let's highlight that because we may want to use it in other parts of the problem. Okay, so now it says, what if d is equal to 0? So this is part B. I'm going to try to stick this part right in here so we don't run out of room on this problem. So for B, if x is 0, well, could we figure out what y was? Could we? Yes, we could, because we know y is equal to x squared minus 8, right? So y is equal to 0 squared minus 8. So y is equal to negative 8. Okay, so what is d if x is equal to 0? So for the point P is now 0 comma negative 8. Okay, do you know where that is on the graph? I hope so, right? I hope you know that that is at the vertex. So this is that point, 0 comma negative 8. Okay, now the D, therefore, is just that vertical line between 0, negative 8 and 0, negative 1. Hopefully you know how long that is. But if you're not sure, you can use the distance formula. So the distance would be the square root, and then let's use the 2 points. The point is 0, negative 8 and 0, negative 1. Okay, so for the x's, we're doing 0 minus 0 squared plus, and for the y's, we have negative 8 minus negative 1 squared, and then therefore the distance, the 0 squared is 0, negative 8 plus 1, so that is a negative 7 squared. So that would be 49. The square root of 49 is 7. So the distance is 7. Notice it's a positive 7, right? Because it's a distance. Notice that, of course, that is the vertical distance between 0, negative 8 and 0, negative 1. You could literally count it on the graph if you drew a nice graph. Okay, so that's part B. Now, of course, it's going to get a little more complicated because in part C, they say, what is d if x is equal to negative 1? Okay, well, if x is equal to negative 1, of course, we'll do the same thing. We'll find out what y is. So y equals x squared minus 8. So that's negative 1 squared minus 8. Notice I did put that negative 1 in parentheses. Okay, I want to square the whole x. So y is equal to 1 minus 8, negative 7. So now our point P is negative 1 comma negative 7. Okay, so now we are finding the distance between point P and 0 comma negative 1. Really, for these problems, even B and C, you have two choices. You could use the original distance formula, which is what I did in B, or you could use the formula that you came up with that was the d of x in part A. My guess is most of you would just go back to the distance formula, so that's what I'm going to continue to do. So d is equal to the square root. Remember, the 2 points are the P, and the other point is always the 0, negative 1. So let's do that. Negative 1 minus 0 squared plus negative 7 minus negative 1 squared. Let's simplify that. That's negative 1 squared, so that's 1 plus, and then this is negative 7 plus 1. I missed a parenthesis again there. Boop. And then negative 1 plus, no, sorry, negative 7 plus 1 is negative 6. And then negative 6 squared is 36. Awesome. Okay, so now my answer, my distance is the square root of 37. Okay, that is totally fine. Notice the point is negative 1, negative 7. So it's right here, negative 1, negative 7. And then we're looking at the distance between this point and that point. So yeah, it's just a decimal. It's a little bit more than 6, right? Okay. That was part C. Now for part D, it says use a graphing utility to graph the function that you created. You are graphing in D, you are graphing the d of x is equal to the square root x squared plus parentheses x squared minus 7 end parentheses squared. What we came up with in part A, right? So you're going to want to pull out your calculator. And if you use a TI calculator, then I'll show you what that would look like. And if you use, don't have a calculator like that, you can use Desmos. And Desmos is really easy to use. You can get it as an app on your phone, or you can just go to the Desmos website, just desmos.com. It's a completely free program, and there's no ads or anything. It's actually really awesome. And it's really self-explanatory, easy to use. So that's why I'm going to show on the TI, because that's actually a little harder than Desmos to use. And I think most of you will have this TI calculator. All right, so what I've done is I've gone into y equals, okay, so right up here where I'm pointing, y equals, and then I just typed in my function, right? So to get the square root, see the square root is right here, and that is the second button. See how it's blue? So you hit second and then square root, and then you'll type in x, and then the squared button is the front of the square root button. So you just type x squared right there. So this is the x button, x, t, theta, and that is the variable button. So x and then square it, plus here's some parentheses you can use, and then x and then squared minus 7 and then squared again. If you have not done this a lot on the TI, I highly encourage you to just practice on it and just try things. The great thing about the TI calculators is you literally cannot break them. You can just type and type. I mean, unless you throw it out a window, then it will definitely break. But by typing things, you will never mess it up or break it where it cannot be easily fixed. So just experiment and try things. And also, if you're stuck on something, I would encourage you just to Google how to do something on a TI-84, and there are videos out there. There are step-by-step explanations of how to do everything. So it's pretty easy to find information on the TI because so many people have used them over the years. Okay, so see how I did graph this. And this is what the graph looks like. So in order for you to see the graph, you type this in y equals, and then you hit graph. So if you hit graph, you will probably faster than me see this lovely graph. Okay, and so all we're going to do on our paper for part D is just to kind of do a little quick sketch of what we see, because it just says use a graphing utility to graph it. So yay. And then for E, it says, for what values of x is D the smallest, right? So remember, this would be x, and this graph represents D. So this is the distance. So they want to know, where is it the smallest? So now I'm regretting drawing this graph so small. Here and here. Okay, so we need to find those 2 points, and that's kind of why I'm doing this on the TI, because you need to know how to calculate the maximums and the minimums. And on the Desmos, you can just tap on the screen and it shows you them, so it's like really easy. All right, so we're going to go to calculate to find this. So calculate is up here. Everything to do with the graph is going to be on the top here. So see calculate there, so I have to hit second, and then the trace button. That makes calculate. Notice I can calculate the value, the zero, the minimum, the maximum, and the intersect. I don't need the last two until calculus. So I'm going to calculate the minimum, so I'm going to type number 3. Okay, then it's going to ask me for left and right bounds. So notice I'm looking at the bottom of the screen here where it says left bound. So just go to the left using the left arrow. Even if it looks like you're going up and down, you're really going left and right. Okay, so just go to the left of it, hit enter. Okay, then it says right bound. So then go over to the right of the minimum somewhere. Doesn't matter exactly where. I could go here, I could go a little bit farther. Okay, I could go a little closer. Just make sure that you're on the left and the right side of the minimum. And then your calculator, now it says guess. you can be a terrible guesser and just hit enter again. You don't have to make a good guess. Notice then your calculator is finding where is the lowest point in your boundaries. Okay, so it's always left bound and right bound, and then you find it. All right, so it says our point, the first minimum that we found is negative 2.55, comma, 2.59 or 60. Okay, so notice that the problem says for what values of x is d the smallest. So the first one that we actually have one of them. X is equal to negative 2.55. Okay, next we're going to do it again because we have to find this other minimum. So let's see, we're going to second calculate. It's good practice, right? We want to calculate the minimum, so you can arrow down to 3 or you can type the number 3. All right, then arrow over. Keep going until you're a little bit to the left of your minimum. See, I'm still to the left of it, even though I was hitting the right arrow. Enter. And now go over to the right of the bottom. You can do this. I am not good with left and right, and I can figure this out, so I know you can do it. All right, and then it did look pretty symmetric, so the other one is the other point. The minimum is 2.55, comma 2.60. All right, so our other x value is 2.55, and we're done.